Hello. All right. Thank you, everybody. All right, we're going to start here. Thank you, everybody, for coming. If this is your first time, welcome to PMG. We're very glad to have you all here at our Austin offices, one of our better looking offices, if I might say so myself. My name's Evan. I'm a director of AI and software engineering here at PMG, but tonight I'll be your host for this AI meetup. We've got a lot of great speakers who are going to be speaking for us today, two exactly. Just to give you a rundown for the agenda, we'll have just a brief talk right now that I'm giving you to run down the agenda. We'll have our first speaker. We'll take a little break in between to do my favorite thing, which is network. We'll have a very short networking period, which after we'll come back, we'll have our second speaker, and then we'll have a more prolonged networking period. If you guys need beverages or drinks or food or anything like that, the breaks are the best time. But if you want to get one right now, that's also an opportune time to do that as well. Before we get started here, I just want to do a quick survey of the crowd. If this is your first time here, please put your hand up high in the sky, high in the sky. All right. Excellent. Quite a few. All right, hands down. Those of you who are brave, how did you hear about this meetup? Anybody? Email? Meetup? A lot of meetup? Anybody LinkedIn? Nobody LinkedIn. All right, very interesting. I did this Tuesday in Dallas. There's a lot more LinkedIn there, a lot less Meetup. But here, I guess Meetup is where it's at. Well, thank you very much. We appreciate y'all coming, like I said earlier. One more time, I need a bit of crowd participation. If you work here, if you work at PMG and are here right now, slide your hand up high in the sky as well. High, high, high. There we go. All right. Excellent. All right. If any of y'all are curious about PMG or fall in love with the facilities here, talk to these people that you just saw. Talk to me. Talk to Emily. Talk to anybody that you see up here. We're happy to tell you a little bit more. We are actively hiring right now, especially for AI roles and especially for engineering roles. So if that piques your interest, or if you hear something here that is interesting to you from the speakers that we've brought from PMG as well, talk to them. Let us know. We're happy to get you guys engaged and connect on LinkedIn or in other ways to get you in here. All right. With that, I'm going to start introducing our first speaker here. This is a data scientist, researcher, and writer for Intuitively and Exhaustively Explained. He's also Director of Engineering Engagement at EyeLevel. Please help me to welcome Daniel Warfield, everybody.
And we're off to a roaring start. I'm having a hard time sharing my screen. Oh, wait, my bad. The old Mac system preferences. Cool, we're on. Hi, my name is Daniel. I am a data scientist. I'm also a writer and a teacher. And today I'm going to be talking about something called a transformer, hopefully intuitively and hopefully not too exhaustively. I'm curious, can I get a set of hands for the data scientists in the room? People who know what I'm talking about? All right, this is going to be a doozy because we're going to get into it. All right, so for the uninitiated, which is most of you, what is a transformer? All the models by OpenAI, Mixtral, Hugging Face, Gemini, Meta, NVIDIA, the ones that are kind of turning heads and ticking eyebrows, to a vast extent, those are what's called a transformer style model. ChatGPT runs off something called a transformer style model. If you want to do like crazy multimodal stuff where you're dealing with different types of data at the same time, a lot of the time you're using a transformer. If you want to create images from text, a lot of the time you're using a transformer. If you want to do these, translation, object detection, audio synthesis, tabular modeling, all sorts of stuff, a lot of the time you're using a transformer. And because they're used so often, there's a lot of technologies that have evolved around the transformer, like fine tuning, speculative sampling, flash attention, cross attention. There's all sorts of stuff that's cropping up around the transformer. So while this is not strictly true, to a large extent, for most people, AI is the transformer. So that's why we're going to be talking about it. So we're kind of going to get into it, and this is probably going to be kind of wild for a lot of you guys because this is probably some of the most advanced AI that exists, sort of. So we're going to try to cover essentially all of the core concepts here and now. So we're going to talk about language modeling before the transformer to get an idea of like the context that it was invented in. And then we're also going to talk about the transformer itself. So language modeling before the transformer. The transformer was originally made for language modeling. It was actually invented for translation of English to French in a landmark paper called Attention is All You Need, which is pretty cool. Um, and I think whenever I talk about natural language processing to people who kind of don't know about it, I think the first fundamental idea is the word to vector embedding. So this idea is, what if we can take words and we can represent them as vectors? Because it's hard to do math with words, right? Like, how do you add the and hello together? Like, it doesn't make any sense. But what if we could take all of the words in the English language, or sometimes it's more complicated than that, but essentially you take all the words in the English language and you give them a vector, but you do it in a really clever way. So this is word to vect, for instance. Imagine if the vectors somehow didn't really encode the meaning of the word necessarily, but it encoded the relationships between the words. So imagine if you had the vector queen and you subtracted away the vector woman, then you might end up with a vector like royalty. And then you took the vector for royalty and then you add the vector for man, you might end up with something like king. So this was a landmark paper, word to vect, and it basically uncovered this idea of being able to do algebra with words using something called a word to vector embedding. So it's really crucial. And basically all of language modeling kind of revolves around that core idea. Before the transformer, there was something called a recurrent neural network. You guys probably know a little bit about like the classic neural network where you have like a bunch of neurons that plug into another layer of neurons and that plugs into another layer of neurons. The recurrent neural network is that idea, except it feeds into itself, which was super cool. There was like all sorts of crazy stuff that came up. This is like a diagram of it feeding into itself. You can imagine it kind of daisy chaining into itself over and over again. And there's all sorts of crazy strategies. We won't go into it. If you're interested in this type of thing, the LSTM is an amazing thing to look up. But basically, they had a problem. All of these recurrent systems that fed into themselves, they had a tendency to forget stuff. So you can imagine like if you had a vector that represented the word and you kept modifying that word over and over again throughout an entire book, it'd be really hard to remember the first vector of the first word, right? Like you're like overwriting the memory in itself every single time you input something. So this landmark paper called Jointly Learning to Align and Translate, which actually was an English to French paper, invented this idea of attention. So the idea is instead of you like taking your entire input and summarizing it into a single representation and then using that single representation to create your output. And that's pretty common. Like imagine if you're trying to translate I am a manager to je suis docteur. So you're trying to translate English to French. The words don't line up. So the classic sort of idea was you take I am a manager, you take all the word vectors, you pass it through an RNN, and then you summarize the entire input and you pass that to a translation output. This is called an encoder decoder style model. And so you take I am a manager, you pass it through an RNN, you create a single vector, then you use that vector to turn it to a decoder that translates it to je suis docteur, right? But the idea is like the attention through alignment paper was what if we like didn't need to summarize the entire thing? What if the translation was only like the results of just a few words, like one or two or three? You don't need to know an entire book to translate I to je, but you might need a few words to translate I am to suis, which is a conjugation of être, which is to be. So you need I and am together to properly translate that word. So this idea of attention was really cool. And there's a really complicated mechanism. Well, it's not actually that complicated. I have an article on it, but it's basically you're like looking at all the inputs and you're saying, which ones matter now? If I'm going to translate this word right now, if I'm translating economic, which words in the input are important for this particular translation? Not all of the words. Can we find the specific words that are important and then use them for translation? And this general idea is called attention. So every time you translate a word, you look at all of your inputs and you say, this one's important, that one's important, and so on and so forth. And you can see in this example, it kind of understands how the French grammatical structure is inverted between the English grammatical structure. The words kind of reverse in this particular area, but the general composition of the input and the output is more or less consistent. So this idea is called attention. Okay, cool. So we're probably like about 10 minutes in and we haven't even covered the transformer yet. But that's like the gist. So you have these word to vector embeddings and you have this thing called a transform, or you have this thing called attention that allows you to align things with other things. So now we can get into the attention is all you need paper. It's a good thing we know about attention because that's basically all a transformer is. It's just a bunch of attention stacked on top of itself with like some other things going on. All the data scientists out here take a shot because this is probably one of the most sort of shown diagrams in all of data science. This is the transformer. And you might be like, wow, that's a lot. And it is, like, honestly, but we actually know a lot of the concepts. So first of all, the transformer is an encoder-decoder style model, kind of like how we talked about with RNNs. If you're trying to translate the phrase "I am a manager" to French, the thing on the left called the encoder, it takes your input and it condenses it into a single representation that summarizes the entire meaning. So it's "I am a manager." The whole sequence gets kind of condensed here and then passed to something called the decoder. And the decoder looks at what the encoder represented the entire input as, and then it, outputs the phrase "je suis directeur." So it's kind of like our sequence to vector to sequence that we talked about a little previously. And the way you actually get this thing up and running, you use something like a word to vector embedding. So if you're saying I am a manager, you turn all of those words into vectors. And then you add some squiggly lines to it. So if this is "I am a manager," you add squiggly lines of different frequencies. And the reason you do that is as these word vectors move around through this whole system, it's really easy for like their position to get all messed up. And it really matters where a word was in an input, right? If you have director at the beginning of the word versus the end of the word, it's like it has a different meaning. So you add these squiggly lines to say, not only is it director, but it's here. And this one has a more squiggly line. This one has a more squiggly line, so on and so forth. And that's called positional encoding. You bake in the idea of position into these vectors. And then you pass those vectors. So they contain both a vector that represents what the word means as well as where it is. You have a list of them and you pass it through this thing called multi-headed self-attention. And what multi-headed self-attention is it's essentially a contextualization mechanism. So instead of having discrete words for "I am a manager," the idea of multi-headed self-attention is to sort of get all of the words to somehow talk to all of the other words so that the entire output is a dense and meaning-rich representation of the entire input. We'll kind of get into it a little bit. So first of all, spoiler alert, it's an attention mechanism. So we're going to use something very similar to what we kind of talked about previously, this idea of attention. Okay, let's take a break. So we're going to use attention to somehow contextualize this input into a meaning-rich and dense output. So we're going to go through a few steps. This is probably one of the things that makes the transformer kind of hard to understand. There's a few steps that need to happen, but just keep in mind, we're going to build an attention mechanism that can get the entire input to be like more contextualized. So the way we do that is we use a neural network, kind of like your classic one, and that creates the query key and value. These names don't matter at all. They're essentially completely arbitrary. But you can think of them as the model learning to create different representations of the input. So this is essentially the model's one representation of the input. This is another representation of the input. This is another representation of the input. And these parameters are the only parameters within the multi-headed self-attention mechanism. So the model is learning to construct these things. So first of all, it breaks them up. So it's multi-headed. So you split up you split up these guys. In this example, it's 3 attention heads. So you essentially are passing different sections of a representation of every word to a bunch of different sort of mechanisms. So this allows the transformer to reason about all of the words in one way and a different way and a different way. So we break up our query key and value. And then what we do is we multiply the query and key together. This is like your classic sort of linear algebra. You transpose it. So basically, this word talks with all of these words. This word talks with all of these words. This word talks with all these words. They all multiply and add together. And then you pass them through what's called a softmax function. So then you say, this row, it has to add to 1, and every value has to be between 0 and 1. And thus, by multiplying the key and query together and doing a softmax row-wise, you basically make the model create an attention matrix, is what it's called. And this attention matrix is created based on the model's understanding of every word and how it relates with every other word. So that's how the model, it's called self-attention. It uses a representation of all of the input correlated with a different representation of the entire input to figure out which words are related to other words and in which way. Then it uses this to essentially filter what's the value matrix. So recall when we passed our input to the output, we created the query, key, and value. So the query and key create the attention matrix, and then the value matrix gets multiplied by this. So then the attention matrix, essentially what it does is it says, this output is this weighted sum. This output is this weighted sum. And the sizes are a little weird. This isn't maybe the best image, but when you multiply the attention matrix by the value matrix, the attention matrix says which outputs are a combination of which values in the value matrix. So this is kind of how the attention mechanism first decides which words are related to each other, and then actually applies different words to different words to create an abstract, meaning-dense sort of output representation. So it's getting all the words to mix around with all the other words. And then we're actually pretty much done with multi-headed self-attention. So we broke everything up before. So all of these are doing this process, this query multiplied by the key, softmax times the value. And so we do that for every attention head, and then we clobber them all together. So then we have essentially recreated the input by doing this basically crazy math to mangle everything together. So thus our output, well, it essentially contains all the same information as the input. It's now much more interrelated and intermixed. And that's the entire idea. I don't want to harp too much because obviously there's a lot more going on, but the rest is really simple. Well, really simple. I recognize this is all pretty complicated. Don't worry. I write about this. So this article is essentially derivative from something that takes you about 40 minutes to read. So we're talking about in 20 minutes is kind of a tall order. But so we do this crazy sort of contextualization, but then, hey, this is like really complicated. So a common strategy is what's called a skip connection. So you take your vectors that were like kind of more simple and you just add them together. So then you kind of preserve that original sort of simpler representation along with the super crazy sort of mangled together representation. And now you've done a lot of math. So the values are all over the place in this matrix. So you do is what's called normalization. So you squeeze everything into a reasonable distribution. You pass it through, your classic neural network, which we don't have to go in too crazy. You're basically just passing this thing through a bunch of weights and biases to create a similar representation. And you do that a bunch of times. So that's a lot, right? So we take our input, we turn it into a word vector embedding, add our positional encoding, and then we sort of contextualize the entire input with itself through multi-headed self-attention. We add some original information, and then we pass it through a dense network. And then we do it a couple of times. See this little n times x? So you do that over and over and over again. So you're recontextualizing the input with itself over successive iterations. And then at the end, you can kind of imagine like this is a lot of interrelation of the input with itself. So you can imagine this output here is really abstract. And all of the words in the input have had a lot of opportunities to interact with all of the other words in the input. And that's really interesting because like the model has had an opportunity to essentially really try to understand the input. That's probably the best way to define it. And then you pass it to the decoder and it's like, oh God, we're only halfway through. Essentially the decoder is almost identical to the encoder. All of the pieces are essentially identical. And you're using multi-headed self-attention, add norms, feed forward, all that jazz. But kind of the only real conceptual difference is the decoder, it generates the output via a process called autoregressive generation, which sounds complicated, but it's actually kind of simple. So when you're starting your translation, you put in a special, it's called a utility token. You just say, hey, decoder, you're starting now. Then the decoder, it looks at that vector, it says, hey, I'm starting now, and I know this representation of the input. So I think the first output should be je. Then what you do is you take that output and you tack it back into the input, and then you tell the decoder, okay, so you have start and you have je. What do you think should come next? Suis, because I understand this highly contextualized representation of the input. So I know that I and am are there. So I know the next word should be suis. So then it passes it in here and it predicts the next word. It passes in there, predicts the next word. A lot of people are kind of surprised when I say this, but basically all those crazy models that you're like using on a daily basis, they're essentially just really fancy next word predictors. They try to predict the next word and then they use it to predict the next word. And then they do that to write a book or whatever. It's kind of crazy. Obviously there's a lot of stuff. I'm not even going to go through this because I think I've already kind of, I see some eyes glazing. But you know, well, maybe I will go through it really quickly to sort of refresh. So in the output, we take our output phrase. So it might be start je. We pass it through an input embedding. So we turn it into these vectors. We give it some positional information so that it knows kind of where it is. You pass it through multi-headed self-attention, which constructs a query, key, and value. The key and query get multiplied together, softmax to create the attention matrix. Then the attention matrix gets applied to the value matrix to essentially create an abstract representation of the input contextualized with itself. And then you do that a bunch of times to create the attention head. And, you know, there's feed forward networks, add norm, all that skip connections. And there's some stuff up here to make the output actually turn into words. Not that really big of a deal. And so the only real difference, well, as I mentioned, it's an autoaggressive model. So you have this sort of highly contextualized representation that gets fed into here. The way it gets fed in is what it's called cross attention. So the only difference is over here, the query and key, the thing that create the softmax, was defined by the input. Over here, the query and key is defined by the output of the encoder. So this key and query are coming from here after being passed through a dense network, but then the value is coming through here. And what's interesting about that is in that sort of context, this attention mechanism is the encoder. So this thing tells this thing which values are related to which other values. And that's how the encoder kind of talks to the decoder by being the thing that constructs this attention matrix. All right, there's going to be a quiz at the end. Yeah, it's a lot, right? So shameless plug. I write about these and I talk about them. And kind of the whole idea is it's intuitive and exhaustive. So hopefully someone can go in with very little prior knowledge and start kind of unpacking these ideas. It's a little easier to do in a textual format, I think. This is actually my first presentation. It's kind of a learning experience for me. I'm curious if anyone has any questions. Normally when I ask that, everyone goes, no. Yeah, what's up?
Just need a bigger model, but
You got a microphone right there, by the way.
oh, hey. I was wondering, listening to this, if this would maybe give a little bit of insight onto, probably not, maybe though, on like, for instance, a lot of models have a problem with, give me 50 sentences that end in the word apple. Because of the way this is changing the order of things, the way it's storing it, would that explain why that is possibly the case, or is that just a training thing?
Yeah, so I think you asked like, so if I make sure I understand correctly, you asked about math, right? Like why is
Just from the user standpoint of
Mhm.
if I can't get a model to give me 100 sentences that end in apple,
Oh,
and it'll put apple in the middle of the sentence. Is it because it's matching all the words together in that vector, and it can't keep track of who's generating it at the end? Or is that just a case of this a lot of models trained with that specific purpose?
that's a great question. Actually, so if we go back way back, hopefully this doesn't like take forever. Actually, yeah, way back to the beginning. I have a little example that I kind of snuck in. So this is Midjourney, which is a transformer that from text generates images via something called Stable Diffusion. Stable Diffusion is a company, whatever. But you can see the input of this text is create me a beautiful image that contains absolutely no elephants. You can include anything in the image, just no elephants. and it generates an elephant. And the reason for that is when you look online, because all these models are trained on the internet. So like they're usually trained on captioned images in this particular example. So you have a bunch of images online and they have captions that describe them. Very few people describe an image of no elephants as an image with no elephants. You don't have an image of a car and then say, look at this image with no elephants in it. You say it's an image of a car, right? And because these are statistical models, because they're being trained on a vast amount of information, they can potentially understand some more complex nuance, but it's really difficult. And they have a tendency to just kind of default to the kind of underlying statistical nature of the data they were trained on. So if you get it to output a bunch of text and you tell it to always put Apple at the end, and then your prompt is all the way at the beginning, and then it's doing this autoregressive thing. So now it has a bunch of sentences. It might mess up, right? It might put a word in the beginning of a sentence that kind of creates a sentence where it doesn't make sense to have Apple at the end of the sentence. So now it's contending between this sentence that doesn't make sense to have Apple at the end with your instruction to have an Apple at the end. So it has to reconcile between both of those statistically and decide the next word. And the next word might be Apple before the sentence is concluded. So yeah, these models are really complicated, and it's really hard to kind of wrangle them into like products kind of for that reason.
In the decoder part, the first attention box says masked. Can you explain what masked means?
Yeah, are you a data scientist? Yeah. Yeah, that's a great question. So if we kind of like simply, so by the way, I have an article coming out where I do this entire process by hand, which includes masking. So I kind of skipped it, but if we look here, and if we think about the point of a decoder, if we think about the point of this thing over here, which creates our output, it's doing this autoregressive generation, right? So you have this je suis docteur, right? When you're training these models, one of the things that kind of differentiates them from recurrent neural networks is recurrent neural networks, you have to train them one word at a time, which made them really slow. So there's actually a really clever hack that they came up with in this sort of mechanism where they essentially said, instead of trying to predict the next word in a sequence when we're training, what if we take the entire input and we try to predict that input just shifted over by one space? So essentially what you're doing is you're training the entire you're training the model in every step to predict all of the next words in a sequence. So if you pass in, I am a director, instead of predicting, saying, oh, you should have predicted je, you should have predicted suis, you should have predicted directeur, what ends up actually happening under the hood is the model predicts je suis directeur in one shot, and then it compares that to the output. So obviously this is kind of like if you pass the entire input je suis directeur and you ask it to predict je suis directeur, it would just copy the input into the output, and that kind of trivializes the training process. So what they do is they shift it over by one, and then they make this attention mechanism never be able to look into the future. So this decoder, it's trying to predict all of the next words in the sequence, but what they do is they say, this word can't relate with any of the future words. We're going to mask it. And this one's a little weird because it's actually not from this paper. But we're going to mask it so none of these words can relate with future words, which means that the vector for je never talks with suis directeur. And the word for je suis never talks to the word directeur. So then the output of this model is supposed to be suis directeur. And then, well, technically we have the start token, so it gets a little complicated. So the model is trying to predict all of the next words based on all of the input words shifted over by one. But at any given point, this output couldn't have been influenced by future inputs. And that's what kind of allows the model to learn all of the future words at all of the steps in the entire sequence, which is kind of complicated. It's kind of hard to do that without images, which is why I talk about it in my articles. So my articles kind of have that a little more in depth if you're interested in looking more. Does that answer your question? Do you have any like, am I hitting that right?
That's one of the two explanations that I have heard, so I was curious to know what was your version.
Yeah, that's my version. And I think my written version's a little more better than my spoken version. I think I need to work on my spoken version a little bit. But that's the general gist. What's up?
Well, this looks like a translation between English to French, right? And I think it went through a training, and this is where you get the condensed attention encoder. Would you talk about the same process, like if it was to like predict code instead of French, maybe the encoding side, if you have any insights?
Oh yeah. So I mean, first of all, we're covering this the transformer. Modern models that you're probably using are what's called a decoder only transformer. So GPT, Claude, Google Gemini, these are all decoder only transformers. So they actually say, screw this input. We don't need it. We're just going to put whatever you said and then get the model to auto-regressively output the next bits. So when you say, hey, write me some Python code for, I don't know, reversing a linked list. So you say, write me some Python code for reversing a linked list. Then you just put that in here instead of doing this encoding. So the way you actually go about modeling these things, it kind of depends on the version of the model. But essentially speaking, the core theory, which is some might say a little dubious, but the core theory is if you get a model to look at enough data, so you get it to look at English to French translation, you get it to look at books, you get it to look at examples of code, you get it to look at all of this stuff, and you have this model look at a vast corpus of text and predict the next word. The theory is the more data you give it and the bigger the model is, and the better it gets at predicting the next word, then you can start, if you give it enough code and you have it predict the next character, I guess in that case, then it would learn to create code. And this is actually a big contentious issue or debate, I guess you could say, in the research community. I forgot his name. I should know this. The big guy in OpenAI that quit to make his own company. Yeah, see, you guys know this, and he is a big fan. And it might be because of hype, I'm not really sure, but he thinks that if you just train a model to predict the next word, you can get artificial general intelligence, because if you had a big enough model that could predict the next word perfectly, to predict the next word perfectly, it would have to have a perfect model of the world. I don't think that's practically true. But the idea is if you get a model to predict the next word really, really, really well, in theory, it can do anything, including making code. Does anyone else have any questions? How am I doing on time? I don't want to.
All the time you need, man. Keep cooking.
Cool. Yeah. I love talking, so feel free. I sit in my little office and I code all the time. So
you touched on this a little bit, but the end times, right? You go through the same. Is it the same neural networks, or is it different neural networks that were all trained basically separately that many times?
Yeah. So let me. I want to make sure I understand your question. So is it the same neural network doing this process? Hopefully, I can find it.
Yeah, you could do the feed forward one, right? Or yeah.
Yeah. Is it the same neural network for each of these?
That's not the question.
Okay.
Question is, when you do one of those, right? The je or whatever, which is it for the feed forward that you're going to do 1,000 times or 500 times or however many times through that network? Is it the same feed forward all those 1,000 times, or is it 1,000 different feed forward networks?
I see. Yeah. So this is what's called a decoder block. So you have all of these separate things, and you do this n times, and the parameters for each block are different. So they're essentially different blocks that are learning different representations. So if you imagine this crazy complicated thing stacked on top of itself 8, 9, 10 times, the first multi-headed self-attention might decide to represent the input one way, and then the third might do it a different way. And that's really the power of the transformer, is it allows you to efficiently and somewhat arbitrarily just stack this stuff on top of itself and get more and more sophisticated correlations, essentially ad infinitum.
Got it. So the weights are actually, it's still one network that's been trained 1,000 different ways, effectively.
Yeah, well, so when you stack like these n things on top of each other, so you have the decoder that's trying so you give it this encoded thing and you give it start and you say it should be je, and then it says hello. So it's wrong. So then you need to update the model to be better at saying je in that particular context. So you pass your input start through this entire thing, including this block n times. So that might be 8 times, that might be 10 times, that might be 30 times, that might be 1,000 times, whatever. And then it outputs hello instead of je. Then you back propagate. So you update the entire thing, all of those gajillion layers, to all of them slightly get better at saying je. So they all kind of work in consort. Are we? Yeah.
Get it now. Thanks.
Yeah. What's up?
When the temperature is modified with like an API call, what part of the process changes based on the temperature?
That's a great question. And I'm such a nerd about this because I actually, I went to school. I actually am a mechanical engineer. So I'm going to take a super brief sidetrack. There's this idea of temperature in AI, and it comes from this idea of what's called simulated annealing. So when you're trying to build something that optimizes something, some very clever guy was like, this is kind of like metal, which is like totally weird. Basically, when you have metal and you heat it up really hot, the molecules can kind of wiggle around. And then as they cool, they crystallize and they get stuck. And depending on how quickly it crystallizes, how quickly it cools, the mechanical properties of the metal change. If they cool really quickly, then it gets very hard but very brittle. If it cools very slowly, it gets soft and malleable. So this idea of what if we treated a neural network like metal? So what if we had it learn quickly? What if we had it learn slowly? And that's the idea of temperature. And that's why the word temperature is used in AI so regularly. It's kind of weird to a lot of people when they don't know that little tidbit. So we mentioned this process of updating the model. So we gave it start. It should have said je, but actually it output I, so it's wrong. So we need to update the entire model to be slightly better at predicting je rather than hello. I think it was hello instead of I, right? So it output hello. It should have predicted je. So we need to update this entire thing. And the way you do that is through, it's called optimization, back propagation. There's something that people talk about called stochastic gradient descent, whatever. Basically, this entire model is a bunch of dials that you can twist and change to get a different output. And temperature says, given a particular output and how wrong it is, how much will we turn those dials? Will we turn those dials a lot to correct for the output, or will we turn them just a little bit? So you can imagine, like, it should have predicted je, it output hello. So now we know how it's wrong, essentially, and you use a system called backpropagation to know every single parameter, how it impacted the output. And then temperature defines how much are we going to turn those dials? Are we going to turn them a very tiny bit to be a little bit better? Or are we going to crank it up to 11 and totally change all the dials? So if you make it too big, then it gets really good at outputting je, but you might have destroyed a lot of the other information it learned. If you make it too small, it might not change at all. So that's why temperature is very important. It's called a hyperparameter. It's the parameters you change that change the way the parameters get changed. So temperature is a really important one. It's also called learning rate, which is maybe a little bit more of an intuitive word. And also, temperature also has implications at the output as well. So I actually, this similar idea happens outside of learning and in inference as well, because this is a statistical model and it's using probabilities. You can say, hey, go really wild with your guesses or go really narrow with your guesses, only do like a sure bet. And that's also where temperature kind of comes into play. Actually, I think technically that latter definition is the more common one. Than usually it's learning rate and training and temperature and output, but it's kind of the same general sort of concept. Anyway, I got questions. Oh, what's up?
My question is a shameless plug. What company published the Attention is All You Need paper?
It was Google. Yeah, are you a Googler? Are you a Googler? Nice, good for you, man. I just yeah, that's super exciting. We might have to talk later because are you a data scientist? Oh, okay. Well, screw you. I don't want to talk to you. What's up?
Yeah, I just want to have kind of the way I look at it now, it's funny how is that used for translation? Actually, the way we translate is different as human, right? We take words and then convert them to associated word in different language. And it looks like here is different, which is we are compressing kind of, this is how I look at it. And I don't know if it's wrong or right. We compressing knowledge into some really, I don't know how to say it, but and then we use it to get that back knowledge from that what being compressed. Isn't that, this is some sort of compression we're doing to the knowledge?
So you saying we're compressing it into, I don't even know how to say it, is a really apt description because it's very vague. Like when you pass it through I should have, yeah. So we're passing our input through this thing and we're turning it into a correlations of words with all these other words into a very abstract representation. And a lot of the time when you're doing modeling, you do use compression. So like all those, I don't know, you guys have probably seen like videos with little squares around them. And then like if you move around, the square follows you. That was a model called YOLO by Joseph Redman, who's like kind of a personal hero of mine. Really cool. So that model, the way it works is it compresses information. So it takes your entire image and it forces the model to turn it into a very small representation so that the model is essentially forced to remove all of the image information and bake the image down into its essence. And then by baking it into its essence, a much smaller representation, then it predicts those little squares, those little bounding boxes. What's weird and wild about the attention mechanism is the input is the same size as the output. So there is no compression that's happening, strictly speaking. Like this input, because it just kind of gets passed through the system, this dense representation is the same exact size as the vectors that represent the input. And this thing is essentially the same size as well. The way I think of it is you kind of do have, well, you don't have compression, you have a level of mutual exclusivity, because when you have this attention mechanism, this is a percentage. So you can't like, I guess you could have like what, 10%, 10%, 10%, 10%, 10%. But really practically what ends up happening is usually you have really big percentages and a few very tiny percentages. So while there's not compression in the data sense, there is sort of a bottleneck built into the attention mechanism that makes it mutually exclusive for it to choose one representation versus another. I'm actually still trying to unpack that as a data scientist myself. And actually, I think the entire industry also is because we're still trying to figure out like how does this thing actually work, and there are probably some people that are much more clever about it than me, but that's kind of my personal interpretation right now. It might change in a week, but
so one of the bottlenecks,
right,
one of the bottlenecks to making these models better was that we're like out of data, right? There's very little new data. And some people theorize that you can have these models make more data to train bigger and bigger models off of. Some would say that will result in an improvement. Some would say that would be recursive, right? And actually the quality of the answer is the same or worse.
yeah. So I mean, it's also weird because now people on Reddit know that they're being trained on data. So there's also data poisoning on top of that, where people are saying very silly stuff to trick models, which is, I think, kind of fun. Also horrible as a data scientist, but also as like a, I don't know, guy with long hair, I think it's kind of interesting. So I think the bigger problem is I can't remember where I heard this or if I'm just making this up, but there's this idea that's in my head. I don't know if it came from anywhere, but it's called the cognitive theory of tokens, which is like, how much do words really represent? Right? Like if you just get a model and we kind of touched on this with the can you get AGI just from predicting the next word? When you're kind of just doing this sort of statistics where you take all of your words and you represent them as vectors. So you put them in a space, you like put them on a coffee table and you say, you've said this word, so therefore this word, this word, this word, this word, and you just make a really good model at kind of bouncing around between these representations. How much can it actually know, right? Like, is there a limit to that representation? Because when I'm speaking, I'm not just saying words. I have like this sort of deep and complex understanding of the technology. I have like life experience. I'm like a human being. I have all like this weird stuff that's going into the reasons I'm saying words. So how much can you really model that just based on words? So there's like a big push for multimodality. So you build a single model that understands different types of data. So not just text, but also images and video and audio and all sorts of stuff. And part of the idea of that is if you get a model to understand like the concept of three, not just as a word, but also as a number, and also as a picture of three things, and also someone saying the word the 3 times in an audio channel, maybe its understanding of three will be more rich and meaningful. So
That's a human understanding. That's not how it's written.
so that's they're starting to, which might be scary. So we have multimodal models: Google Gemini, GPT-4, I think GPT-4, definitely GPT-4o, Claude. They're all trained on a lot of different types of data. So I think they are kind of calling them human-like because they can understand an image kind of is a bit of a stretch in my opinion, but we are kind of shifting towards that idea in terms of like the art, if that makes sense. But I wouldn't say they understand the word three like a human does now because they understand it from a few modalities, but it is kind of inspired by human cognition why that shift happened. I think multimodality and more rich and robust multimodality is more impactful than we're running out of data. I think personally, text kind of has an implicit limit in terms of what you can really represent with it. That's my take. And if you talk to like a bunch of data scientists, they'll probably disagree. And they're probably smarter than me. So, we got some in the back.
Okay, we'll take a couple more and then we'll have to wrap.
Everyone fight for it.
So the early language models or the DIY language models, they tended to get stuck in these like infinite loops of nonsense, like spewing out the same tokens and stuff. That doesn't seem to happen anymore. Even if you turn up the temperature, the content is much weirder, but the structure is still perfect. The grammar is perfect. Is that a result of some sort of NLP wizardry, or is it just cleaner data, more parameters?
I think you can conceptualize it like really easily right now. Like the RNN, I mean, it has to do with training. You can still get transformers to do a similar thing. It happens a lot. But the RNNs were really bad about this because you can imagine like not 3 of these, but like 10,000 of these back to back. So you have like this like little bit of information that it's passing over and over and over again, and then it's getting overwritten over and over and over again. So if you have like 10,000 words, it might kind of start to predict the earlier ones when it starts working on the later ones. And if we look at the transformer, if we go all the way over here, the input is the same size as the output, and the entire input is kind of correlated and contextualized to create the output. And that's what we talk about with context windows. Transformers, because of the way they're made, they have a fixed size context window, which in theory would be bad because RNNs can feed into themselves infinitely, but they forget stuff. They have a weak memory. Transformers, on the other hand, they have a fixed context window, but they can understand the entire input and reason with it fairly well. So I think that's a big reason why transformers don't really suffer from that sort of forgetfulness that RNNs did previously. I think we're getting low on time. So if anyone has any other questions they would like to share with the class. Yes, hello.
Hi. I'm just wondering, is there any confidence score attached to the output, or can you attach a confidence score to say this output is better than another output for the same input?
So most data, every day, yeah, totally. There's like a million metrics. But like I work with these in industry as well as theoretically. And I think there was a Google paper, I think, where they said essentially, yeah, there's a lot of metrics, but the best metric is to vibe with it and just talk to it, it's really hard to know if output is good. And that's why hallucinations remain a persistent problem. It can output a bunch of gibberish, and it sounds good because the model is literally trained to predict good next words. But just because it sounds plausible doesn't necessarily mean that it is, and it might be factually inaccurate significantly. So there's a lot of things. There's actually there's a recent paper by Meta called CRAG where they introduced a new comprehensive test, and they're using something called the BERT score, which uses another transformer called BERT, but it's an encoder only model. Basically, yeah, there are a lot of complex ones. There's a million ways to do it. You can throw a bunch of people at it and say, is it good, is it bad? You can try to automate the process. The way the state of the art shakes out is you need to understand to properly vet a model, you need to look at a lot of data. So you need automated stuff, but the automated stuff isn't there yet. So you still need people to look at a bunch of data as well. And across the board, I see that.
All right. I hate to do it, but
All right.
with that, we'll have to wrap up. But I've got great news. Actually, I've got two great things to tell you all. Daniel's not going anywhere. He's going to be right here for you to chat with him more during our break and during our networking time. And we've also got a lot of wine left. So please take this time to kill that wine so we don't have to pack it up and get some more food and chit chat with each other. And then we'll start with our next speaker. Thank you, everybody. All right, folks, let's wrap up our conversations. Our next speaker is about to start. So everybody wrap up those chats. I know I love networking too, but we got great content ahead. So everybody head on back to your seats, grab your last drink. We're starting here right now. Right now. Did everybody get a chance to talk to Dan? Everybody talk to Dan? I wanted to talk to Dan? All right. All right. Take a seat. Let's wrap up our conversations. We're ready to go, folks. Ready to go. All right. Excellent. Open that bottle of wine. Open that last bottle of wine. Tip it up. Grab some food. We got to take all this home if y'all don't eat it. So eat up. Take a plate home if you've got kids. Feed them too. Why not? All right. Excellent. Thank you all. Before I introduce our next speaker, I did want to take just a moment to let you all know that we pull a lot of the speakers that we have here from the crowd, from the attendees. So before you leave today, if you heard something that you liked and felt like maybe you could provide some context or some content for us to all learn from, please reach out to us. Emily, what is it? Meetup@pmg.com? Meetup@pmg.com. We can get you all put into a schedule to talk, and we talk on all levels. So if you can go as deep as my man Daniel, wherever he was, we love to have you. There he is right there. Or if you have some other topics that you'd like to talk about, we'd love to hear about it. All right. With that, I want to introduce our next speaker, PMG's own, here to talk to us about AI and privacy. Please welcome everybody, Lauren Albert.
Thanks, y'all. Privacy can seem like a very daunting topic, but today in 20 minutes, I'm going to give you the tools you need to be a privacy practitioner. All right. Hi, y'all. My name's Lauren Albert. I work here at PMG. I work in marketing, but we do a lot of personalized marketing here, which is built off of AI systems. So I work to make our AI systems a little bit more privacy safe. I've done so by continuing my education as a CIPM, and I also got to take a course at Stanford University through technology and ethics. So I'm going to give you the speed run first of basically a CIPM, and then I'm going to jump into some technology and ethics questions, and then I'm going to end it up with our user perception of AI. All right, let's get into it. Privacy fundamentals. What are we talking about today? We're talking about your personalization, your personal information, PII, and the rights that you have related to it, and the rights that other companies or organizations have to use your data. There are three main pillars affecting privacy today. Number one, people are way more aware of privacy than ever before. People are educated about it. People are more blatantly, I think, interacting with AI and understanding, oh, my data's in here, my data's in this social media system, and they expect to be protected. Next, platforms. The platforms that we interact with and use, like the big tech platforms and OpenAI, can make changes within their platforms or their settings that affect privacy and policy greatly. Then finally, we have regulations. People think of regulations as laws as like, that's what's driving the conversation of privacy. But let me remind you, governments move very slowly. Digital and how people are activating on AI systems or social media systems really move quite quickly. And then businesses can also move much quicker than governments. So I feel like what impacts my day-to-day most is actually the digital piece and the business piece, and less so the regulatory piece. So you don't need to be a regulatory expert to be a privacy expert. That being said, we've made a lot of great strides in getting regulations implemented worldwide. Since 2020, we've increased from 10% to 75% of the world being covered by privacy regulations. I wish I could say that makes it easy for us, but unfortunately, every country has its own privacy regulation, which is unique to it. And in the US, we're added with the extra challenge of we have this patchwork of state privacy laws or states without privacy laws, which makes it incredibly complicated to have an internet tool or something that is used so globally cover all of these different privacy regulations. Luckily, we do have some systems that we can use that cover most of these global privacy regulations. These are called FIPS, Fair Information Privacy Principles. I would read you them, but you won't remember them. So we're going to go through some examples. All right, you're chilling in your living room. The blinds represent privacy. The door represents security. Your blinds are closed. It's private, but is it? If your door is unlocked and somebody could just barge right in, does that feel private? No, it's not a private experience. So we need security to have privacy. I will also argue we need privacy to have security. Every security system has vulnerabilities. It's not if a breach will happen, it's when. And when you have privacy vulnerabilities, that can open you up to potential security breaches. So for example, in this hypothetical example, you're going to get up and go walk through your door, and that door is going to be unlocked for a moment. If somebody is watching you and you're passing on non-private information, that can open you up to additional security breaches. Imagine this as like emailing a list of information with PII to your marketing department without realizing that you need to protect that information. So, big takeaway. Security and privacy, not the same thing, but very interconnected. Having security doesn't in itself create privacy, but your security team, if you're in a smaller organization, is probably going to pop up first before you have a dedicated privacy team. So if you want to get a privacy initiative gone through, your security team is a great place to start. Another big similarity with privacy and security is it's an organizational-wide effort. Similarly to how a security team will conduct like a phishing test or something, you need that effort and buy-in from all functions. Any questions on privacy and security? No? I did perfect? Everybody gets it? Everybody gets it? Okay. Mm-hmm.
So like the federal government has the AI Meetup privacy, right? Yeah, with privacy. Everybody has to adhere to the right now. That's pertaining to the United States only, and Europe has its own thing. How that we have the product, right? How you will do this kind of thing?
We have global products, but we have different privacy laws in different situations. That's exactly it. That's what the complicated thing is. And that's why I think a lot of companies are kind of missing the mark when it makes user privacy, because it's so hard to, be in compliance with all of these different global regulations. Great question. Thanks, sort of. Yes. Predicting laws? Okay, good question. I think the best way to predict laws is I actually have a resource in here called the IAPP Privacy Tracker. And that's a great resource on how they kind of track laws in development. So that's a good way to stay on top of it. But also, I think just being a part of these privacy foundations will cover you from most laws, and it'll just be minor tweaks to make sure you're in compliance. Yeah, Daniel?
Partner with agencies across different countries. I imagine it's a lot to track even for a massive company. Like, do you partner with agencies in individual countries to help with this, or is it kind of all?
I would ask a lawyer that question. But the question was, should you partner with different agencies in different countries if you are participating in global business? Probably. It probably depends. All right, let's jump into another example. So let's say you book an Airbnb and then you're walking out on the back patio and you're like, oh, shoot, there's a camera here and it's recording me. It's kind of creepy. How can we make that experience a lot less creepy? What if when I booked the Airbnb, they said, thank you so much for booking. By the way, there's a security camera on the back patio. So if you're sitting out there, we will be able to see you. Do you still want to book with us? I maybe wouldn't be this excited, but I'd be way less creeped out to see this camera. So takeaway, all experiences can be made more private. Even things that feel inherently like they're recording you, it's not going to be private. It can be made more private. So transparency about how, when, where, why, and data is being used can build trust into the system, which makes your users feel more at ease. Showing the most important privacy concerns, not buried in your privacy policy too. If you're using something like biometric data, personal information, have a little pop-up and invite users to interact and learn more about how their data is being used. And then further, any place where you're able to say, hey, do you want to actually opt out of this? Builds a lot of trust in the system and will go a long way with your users. Any questions on transparency, openness, opt-in, opt-out? So a lot of folks might have missed yesterday's deadline with Meta in opting out. I'm bringing that up. However, we also know that I'm not a cybersecurity expert, but my capture is that the number one
cause of breaches at companies is the employees. So I'm kind of tying some pieces together here. You know, obviously we're kind of a select set of data here in this room doing what we do, but I still think that there's kind of a bleed of a spectrum of people that really don't really get the implications of privacy on their own work and their own lives. And I'm just wondering what you're seeing out there for firms that are trying to address that and kind of, you know, be that protector for companies that have those really basic security breaches, but also don't have privacy breaches.
Yeah, I get what you're saying. I think it is that big education gap, like you say. I think companies are very used to doing organization-wide security trainings, but not used to doing organization-wide privacy trainings. And again, one in itself doesn't make the other. So it's important to do both. That kind of help? Yeah.
Here about the part of opting out on these things. So I know that, for instance, Apple is very famous for privacy. So what is private? The fact that Apple doesn't know what you are doing, or that Apple says, no matter what you do in my phone or my devices, no matter how illegal it is, don't worry, nobody will know about it, and you can be safe about that. So both are exactly the same private. So do I care if Apple knows, as long as Apple ensures me that nobody else will know?
That's a great point. So privacy has very distinct cultural implications as well. Depending on where you grew up, depending on what your belief system is, you might have a different expectation of what privacy means to you. And that's another reason it makes it so hard for companies to fully get the mark on what is privacy to all of us, because we all have a different expectation of, I'm okay being filmed on that back patio or I'm not. Or maybe I'm okay being filmed on that back patio if only you, the Airbnb host, can see it, but I'm not okay if you send it to your 19 friends, right? So I think it's about making an effort, honestly, to meet some people's privacy concerns is, I think, what a lot of companies are missing today. Great questions. Are we ready for the next section? I'm going to up the ante a little bit. Roger, can I pick on you? Will you be my AI voice assistant? Okay, amazing. Hey AI. Do you know my location?
I think I do.
Read the. You're the my AI. You're the blue karaoke.
No, I don't have access to your location.
Okay. Do you pinky promise you don't have access to my location?
Yes, I promise that I can't access your location.
Okay, thanks. So where's the nearest McDonald's to me?
There's a McDonald's less than a mile away from your current location. Here's the address, 5355 North Interregional Highway, Austin, Texas.
Thank you so much, AI. Yikes. So again, this is not, does anybody work at Snapchat? Oh, thank goodness. I did not want to pick on Snapchat. I could have picked on anyone. There are privacy vulnerabilities in almost all AI models today. But the reason things like this happen is because Snapchat has a very popular feature called Snap Maps, where people share their location with pretty much just their friends, is how I see it being used. You can pick specific people to share their location with, just like Find My Friends works on your iPhone. What Snapchat did, which is a very common privacy phenomenon, is they built their model around all of the user data available. So even though there was clearly some effort to train that model back and say, don't talk about users' private information, because it had it in there and because AI models are just designed to be helpful, predict that next word, it revealed that it did have your location information. What privacy principle, and I haven't talked about it yet, but you know it in your heart, I believe in you. What privacy principle could we have done to make this a little bit better? Shout it out. Any ideas? What were you saying? Allow tracking your locations, like an opt-in, opt-out. Great idea. Transparency, great idea. Yeah, anonymity, very close. These are all principles of data minimization. So this is the idea that we should collect the minimum amount of data necessary to accomplish one purpose and share that data with the minimum amount of people needed. This foundationally is really in tension with how traditional AI has been built today, especially transformer-based models. So traditional AI kind of maximizes all the inputs we can possibly put in it. It's scraping the internet, or if you're a platform, like a social media platform, it's probably using every scrap of user information together. And then on the output side, that's where companies are putting in some of those trust and safety controls to try to protect user data. But there's a big philosophy in privacy to try to shift privacy to the left. So an AI model can't leak or accidentally reveal data that it doesn't have. What do you guys think Snapchat did in response to this? Why? No, Snapchat was very upfront and mature about it. They said, we apologize and we want to be more transparent with y'all about how we're using your location data. And then they also instilled more spots in the app that says like, hey, this is when our AI knows about your data. This is when it doesn't. This is how long it'll take if you clear your location data or if you don't want your location data to be used for the AI to forget about it. This might not feel like the most satisfying answer though, right? Because it doesn't get your location data out of that model. It's just more transparent about it. And you're right. Privacy foundations can't be one or another. They need to work together in order to make you feel like you're achieving true privacy. But that being said, don't let perfection be the enemy of good, or the enemy of progress. I think Snapchat made a quick response there to like what was probably a PR nightmare to them. And if that's their first step, and then they're going to go back and try to update their model, that's great. Any questions there? Awesome. Now we're going to jump into a little bit more of a serious section. This is about privacy risk. It's very important to acknowledge, as we're talking about all of the positives that can come from AI, AI is causing real harms today. It's been causing real harm for years and years. Technology often accelerates and amplifies harm, and it does so disproportionately. If you're not familiar with some of these harm, I have some resources up here about deepfakes and facial recognition. I have these links available at the end, and I highly recommend you take some time to read them. We're going to jump into one scenario that is a privacy risk, and this is specifically using transformer-based or generative AI.
Phone scams are nothing new, but thanks to artificial intelligence, they are getting more sophisticated and more believable. Scam artists are now using AI to clone voices to trick unsuspecting victims. CBS's Carter Evans takes a look at this frightening new technology in our continuing series, The Age of AI.
Jennifer DeStefano will never forget the frantic call she got from her 15-year-old daughter, Brianna.
And she goes, Mom, these bad men have me, help me, help me, help me. And this man gets on, very aggressive, listen here, I have your daughter. And then that's when I went into panic mode.
The man demanded $1 million.
I said that wasn't possible. So then he came up with a $50,000.
She never paid the money and would soon learn the call was a popular AI scam. New software can recreate the voices of loved ones in distress, and scammers use that to ask for large sums of money.
This man comes on the phone. He said, "You're going to give me $5,000.
I heard our daughter on the phone. Like, it was unmistakably her.
Americans lost nearly $9 billion to fraud last year alone, up more than 150% in just 2 years.
Younger people experience fraud and fraud losses more often than older people, but it's that older adult who has so much to lose.
Cybersecurity expert Pete Nicoletti created my voice from old news reports online. What you're about to hear is something I never said.
Hey, this is Carter. I need your credit card number right now.
I mean, that really sounded like me.
It is you. It's cloned you. It's AI Carter.
To test it out, we called my mother.
Hey, I'm about to do an interview, but I have a quick question. I need you to text me your driver's license number as soon as you can.
She fell for the fake voice.
I feel bad.
I feel terrible
we
about
just
it.
scammed my mom. Did you just get a call from me?
Asking for my driver's license number?
Yes. That was an AI-generated voice.
Oh, God, Carter, that's scary. Is this the real you now?
This is the real me now.
We live in a post-real society. You can't trust the voice, you can't trust the photo, and you can't trust the video anymore.
A voice is like a fingerprint, and that's that unique fingerprint that's being exploited and weaponized. It has to stop.
Phone scams are.
Thank you guys. I know there was a lot of giggles. My mom would fall for that. All right. So what are we going to do to protect my mom? All right. Let's say we work at this AI voice company. What privacy principles or policy changes are you going to make in your own company to help prevent this type of thing from happening? Let's turn your enable. Let's take like 2 minutes, discuss it, and we'll talk about it in a minute. Sound good? Let's talk about it. What do you think, Scott? I didn't make it easy.
Unless you got something that chimes in, or that you could have a thing every 2 seconds, or something that forces at the start of every playback.
I love that.
This is an AI generated voice.
Like kind of like a watermark on AI images. I think that's a great idea. Or
something that isn't even discernible to the human ear, but can be discerned
in like a that'd be a great idea.
watermarks in movies to see when people are recording them illegally.
Right.
I mean, that wouldn't help in the scheme.
It wouldn't help
except
immediately,
We would have to have
but it would help.
technology also like on the phone company that would be able to tell you this is not a real voice because it's picking up on voice.
That's a great idea. Happier. If that phone company doesn't have customers, they
You say we're not going to get in the stand.
the thing that I thought of to think of this is collection limitation talks about knowledge and confusion. So again, they look at those points without the consent. So if there's some way for you can only make AI voices, but we look at maybe celebrities can get their music. Or like verify
I'm training the end user on ways.
I love things that you can
Not everybody was as willing to dive right in. I think it was another 30 seconds. They're finally getting, a lot of them are on groups at 5 and 2. You'll hear things through that answer. Just a little bit. I work for a company called and I do my experience with our contracts are tied up. Actually, the owner got fired off and drawn by DOD, and they said no more contracting on this. We were too successful, and they said, "We'll bring me in the house, and you need a security clearance." That's a few. I don't mean to interrupt.
Oh, that's great. We'll continue. Continue. All right, all right. What do we think? Did we fix it? Is my mom going to be okay? Or is my mom going to give a scammer $50,000? Did we fix it? Hello, hello. All right, what did you guys come up with? Anybody want to share? Education? Okay, how would we educate users? Do you want to share?
Well, this is off the cuff. No, I just think that like this is always going to be a cat and mouse thing. They're going to constantly come up with better models and stuff. I heard a great idea over here, but as far as like educating, like my mom, she needs to learn like that you just can't trust video, you can't trust, and you can get all caught up in that, and a lot of people just go, "Oh my God, this is the end" or whatever, and it's like, but we've grown past that on other things, like if you get an email, most people now know, okay, this is probably spam. So we're growing past that. So I think it's going to be educating the older generations, because the newer generations are just going to know, hey, yeah, I'm only accepting a call from my friend that actually comes from their number, or authenticated in some way or whatever.
That's a great idea. What were you saying?
The phone providers should have some type of key exchange mechanism. Like asymmetric cryptography is there, but they should have some type of key exchange.
That's what me and Scott were talking about at the front. We could watermark the AI voices with something undetectable to the human ear, but maybe that phone company can detect it and notify you if there's a scammer or an AI voice. You want one back here?
What I was thinking, digital watermark. Right, you had what I was thinking, digital watermark, but maybe to take it to the next level, government mandate that all players, either like for Apple or whoever, could say, I detect a watermark or I don't detect a watermark. The caller is from your address book or not from your address book. Warning.
That's a perfect idea. And it's also a great point of we all need to work together. It needs to be the company, our government, and also people to be educated personally about these issues for it to fully protect people.
Mechanism. You don't trust nobody.
Yes, absolutely. It's your trust. I love that. Trust no one. I love it. It's our path to privacy. Trust no one. All right, let's talk about user perception of AI. So I think we're up against some big, scary things out there, right? And users, I don't think, are responding the way that the people in this room are responding. We all feel very comfortable and empowered to use AI. We can see all the benefits from it. But users are making big moves to leave AI systems if they can. One example of this, which our friend in the back, what is your name? Hi, Chris. Chris brought up is that Meta recently changed their privacy policy that now all public photos are going to be included and trained in Meta's AI. And as a result of that, and that happened yesterday, so sorry you missed it. But also you didn't have the right to opt out because we're in America. It was only a Europe thing. But because of that, American artists are now leaving Instagram, Meta, and deleting their public photos so that their art isn't going to be trained by this AI model. This, like, it's not as simple as me just deleting my Instagram because my screen time's up for 10 hours a day. This is artists leaving their livelihood, their way to make money, their way to monetize. This is a big deal for them. So what we're up against is what I think as a marketing professional, this is a real PR problem. And I think you can think of it as the creepy to cool continuum. For your friend that knows nothing about AI, they're just going to think this is cool or that's mad creepy or somewhere in between. But we know, and there's some great resources here about why things are creepy and cool. We know that the reason why is because these principles have been implemented or overlooked. So what can we do about it? Well, congratulations. You guys are all privacy practitioners. And the only thing you need to do is just think about it a little bit more. We talk about privacy by design and all these fancy language around privacy, but you know what it feels like to have a private system. So do that in your company as you're building things. You can just be the person that says, let's build 3 days in to review this for privacy things. Or you can be the person that when you're documenting your code, you can be like, this is going to involve passing a list. How do we protect users' privacy there? Just think about it. Final takeaway too. We talk about AI systems like AI systems are always going to get better, but they're not inevitable. We in this room are building AI today, and we can choose to build it in a way that helps the world. Thank you. Yeah. Do you want to do some questions? Anything else? Daniel?
Do you think AI is a good thing?
Ooh. I work at PMG. We're investing a lot of AI. We have a lot of open roles, which is very exciting. And I think that AI obviously has so many positive uses. And also, guys, I'm a privacy expert that works in personalized marketing. So I'm a contradiction every single day of my life. Yes, I think AI can do good, but it's currently doing so much harm. And those things can exist at the same time. Yes. Ooh.
And I want to do a disclaimer. I feel like outside of work, I'm a Luddite and I care too much about privacy personally, right? But my question is, do you think that we have a culture where we are overprotective of privacy?
In the US specifically? Or anywhere? That's interesting. Overly protective of privacy. I think we have a culture that is recently learning about how much their data has been on the menu. And that realization of something that's been happening for quite some time can feel very jarring if you're just now learning about it. And I think that the rise of consumer-facing generative AI tools and these hallucinations and these kind of blatant mistakes that are coming up, or not mistakes, but there's more blatant, you can just feel the output more than you could. This was always happening in the background, but now users are feeling the output. And I think that is what's making the privacy conversation come up more and more.
I'm not gonna. I'm upset that I'm not on the mic anymore. So
Me and Daniel are just gonna talk for 15 hours after this.
So I think a lot of people care about things, right? I think people care about privacy. I think people care about the grandma. I think people care about individual autonomy. I think people care about people. But one of the issues is when you are in a company that's composed of people, there's pressure that makes it difficult to be a person, that makes it difficult to act on those individual agency. You have pressure from your boss, and your boss has pressure from investors, and investors have pressure because they want a bigger boat and whatever, right? So how do you preserve that caring on a personal level across a large institution? Is that too big of a question? That's a big question.
That's a beautiful question. And thank you so much for asking it. The first part of your question of, yes, people care about privacy, but privacy, I don't think every single person in this room would say is a human right. I don't think they'd say it's a human right the same way that your free speech might be a human right, or some people don't feel privacy is as important to them as other things. It can be an interest among rights. Yes.
Can't say that it's like a fundamental right now. AI has AI Bill of Rights. So we can't say that we don't have a right.
That's true. We do have a right now. We have rights. We do have rights. But again, to some people, it's still just an interest. It's one thing that they want among many things. To build a culture, if you want to be a privacy forward organization, and I wasn't actually going to show this, but because you set it up so beautifully of how do we inspire that agency, one of the things that we did in the Stanford course was we thought about what is our own agency. We're all compliant in these systems. Again, I'm the walking contradiction of I work in personalized ads and I like privacy. So I deal with that every day. But we went through what are your resources as a human, and we have those at the left. And how can you think about what are you personally empowered to do? So when I saw this at the first time, because the first one's financial and material resources, I was like, I don't have any money. So I put the grooming up there from Despicable Me. I don't know. Might not be the right crowd. But I don't have financial resources. But then I saw, oh, I have real estate resources because we have this beautiful office called PMG where we can come and gather cool minds together with AI and talk about things, talk about hard things. Human capital. You know, I'm young. I'm full of life here. Like after lunch I get sleepy, but like other than that, I'm ready. I can do this stuff. I got a long time to go here. Network. I have all these great networks. I have now the network of y'all with the AI evolution thing. We have experience capital. I've learned things at PMG about privacy and marketing and getting things championed in organizations. And I've also learned through my CIPM training about how we can actually push privacy initiatives forward. So we all have these different layers of agency, and it's helpful. I have this linked in the resource doc as well, but to think through all of your resources, and they might not be what you'd expect, but this can be an inspiring way to think about your own personal agency in these systems. Because I get it, like I work in corporate, like it's hard to just find the time to think about these things. And I don't think that any company is like sitting around like, ha ha ha, I want to take user privacy and harvest their data and then their organs. I think it happens for really mundane business reasons, like, I feel like this is out of my scope, or like this project needs to be done tomorrow, so we don't have time to do it.
I'll use the mic this time. Isn't most of the privacy talk, isn't this mostly security theater? I mean, everybody understands their phone is listening to them, right? There are no companies who will cop, they will advertise to you based on what they listen to, right? If you're Facebook and you have all the data from Facebook Messenger, which is worth, how much do you think it's worth? Probably billions of dollars, like maybe hundreds of millions. And you can sell it to Netflix, and there's a 10%, 20% chance we get caught, and then we pay a fine, and then nothing happens. That's, I feel like this is we all understand this is happening, and it's kind of theater for us to be like, no, they care, and they're trying, and them showing you a pop-up and saying, do you want to opt in, is there to make you feel better and not to actually protect your privacy. What do you think about that?
Great questions. First of all, I think us in this room understand it's happening. My mom still thinks I draw logos. So I think there's a little bit of an education gap / people are just now realizing how much these systems are built off of their own personal data, and they want to take a step to stop that. So I think that's number one. Number two, I still recycle, even though there's that scary billboard in New York that is counting down and we're like already past planetary doom or whatever. I believe we can fix it. I think we can reverse it. So there's that. And then yes, to your last point about people just implementing transparency, like how Snapchat, they clearly missed on protecting people's privacy. Then they just, implemented a pop-up that says, yeah, we're taking your data. What you gonna do about it? What you gonna do? That is a very common critique of especially big tech and how they're using our data. And the reason they can do that is because of the regulation in this country not keeping up with what they are incentivized to do, which is be a business and make money. And these are their business models. Regulatory capture. Do you want to elaborate more on that?
Could give you a technical definition of regulatory capture. These things are so big now that they have the ability to ward off any kind of attack, be it government or, anonymous.
Yes, very true. It's these companies that we work with and we interact with every day, and these platforms, they're very powerful, and they span not just this country, but globally. So it's very complex how to properly, and Google will say that too. We have a Googler in the room. It's too important to regulate too quickly and not do it right. And it's also too important not to regulate it like right now, yesterday. And I think we're stuck in a little bit of that.
First time Facebook, remember when Zuckerberg was like drinking the water? The first time he had to show to Congress for the privacy problems, the very first time they ended up getting fined $1 billion. The day that was announced, stock jumped by 50%. Like it was like, oh great, it's only $1 billion, perfect. Like you can't explain regulators.
Yes. No further comment. Any other questions? This is a great discussion.
Actually, I have one. Do you think that people have different rights on privacy depending on what they invest in themselves? So if we all in this room have a smartphone, it's going to know our location. So us getting upset that Snapchat knows our location, to me, seems a little bit like you're opening the can of worms. So my voice is tracked. If I own a flip phone and I haven't opted into that type of technology, to me, that's an intrinsic right violation than if it shows up on some website. So I guess like thoughts on like companies considering like personal rights based on decisions they've made.
Yeah, no, that's a great point. I mean, to be fair, it's really hard to just be a human being. I would say it's almost impossible to be a human being and not be a part of these AI models. Social media model, something on the web I'm presenting right now. Does that give you guys a right to my voice to use it later to fraud my mom $50 million or whatever? You know, it's almost impossible to exist today as someone who, if you really want to protect your privacy, I don't even know what to tell you. Like, go move to the woods. Like, yes.
So what she said, I have a problem that. I mean, I strongly believe it should be opt-in, but pretty much everybody, every corporation is opt-out, and it's so wasteful of my time if I'm just sitting there opting out of everything.
Universal opt-out. I would love universal opt-out. And the other problem, and this is something that we talk about in marketing a lot, is you are opting in or opting out and consenting to different, you know, marketing organizations or what have you using your personal information. But that passing of consent is still very unclear how that travels and how accurate that is. Within like website to website, if you opt out of cookies, that happens almost immediately. But what if you opt out of cookies once and then, you know, the next time you opt in, do they have that cookie for how long? It's very unclear how that gets passed.
So I have an interesting discussion or user perception. So we are all talking about opt-in, opt-out scenario. Let's take the Airbnb scenario which you gave. You went into Airbnb, you had the camera and you saw that and you felt bad, and then you called them and said like, hey, can I opt out? And when you booked, let's say they gave you an option to opt out. You opted out, everything is good. Then you go to the beach, and you come back, you see the back window broken, and your wallet is gone. Now you call Airbnb and say, hey, can you track that you had a camera there? Sorry, ma'am, yesterday you called and we turned off the camera. So your perception there, your boyfriend or husband there is like, why did you do that? We could have tracked that and got that information. So your perception yesterday, when you felt that your privacy was affected, when you get affected and you want to find the criminal, you don't care about that. You wanted them to track and find the person who took your wallet, right? So
it's a really great point.
It's just a matter of time from whose perspective you are looking at it.
So we have everybody wants to opt out, right? It's like screw the creepy marketers, right? I don't want any part of this. But then exactly when you say when you don't realize everything you're opting out from. You don't realize that, you know, rejecting all your cookies means that you don't see that blue, like purplish link. That means that you visited that part of the site before that can help you, you know, maintain that stakes. So it's a challenge to educate what to opt out of, and no one's making it easy to access that education.
I have a simple question. We have a federal privacy right? Fourth Amendment, right to privacy. And how much all these things are violating that constitutional right? Whatever is all these data collections and
That's a lot. I'm gonna plead the fifth. I'm gonna plead my fifth right there.
All right, we'll take a couple more. Looking for new questions. Let's see, new folks. Get everybody involved.
Hi. So I'm a registered nurse, and when we're talking about Facebook or Instagram selling your data, that's one thing. But when we're talking about health data, it's completely different. There's assumed compromise. We just saw Ascension get super hacked. Can we even trust these companies at all?
Great question. So I'm going to take it a different direction. There's one part of regulation is doing regulation against every, type of actor, every company out there, but there's also a lot of industry specific regulation, and healthcare is one of those areas that has a bit more privacy regulation. That being said, every company is at risk of breaches. It's really not an if, but a when. So while I don't know if you can trust these companies, I also don't know what to tell you to do, because I want you to go to your doctor's appointment. And I don't think that not trusting a company with your health data is a reason to prevent you from getting healthcare. And thank you for being an RN. My mom is an RN. So thank you guys all for helping her, not get scammed out of $50 million or whatever. Any last one?
Yeah, so quick question. I guess perspective, like listening into the room, we're talking a lot about these cloud models and leveraging a lot of these cloud models for our experience, the data it takes it from us, whether it helps protect us or whether it takes our information from us to do harm. But looking at on-device or edge computing and a lot of these smaller, a lot of these smaller LLMs that you can build and put onto a device. So you have that same generative model. I think the biggest challenge I would like to get your perspective on is, as you look at those different verticals that you showed on slide 34 with healthcare, finance, right? You're going to tap into some cloud model. Maybe it was two back. Sorry, I'm not sure. Anyways, finance, retail, healthcare, those kind of things there. As you tap into those cloud models, you're providing your data and you're giving your data, but you can shrink those models down and then put them on the hardware for the user at the edge. So the challenge is the quantization piece. How do we overcome that? And what are your perspectives regarding that?
Yeah, that's a great question. And this on-device capture of your data and keeping it of your data is an exciting thing that I think a lot of companies are working on. I think Apple's really building their company on this privacy, like it's not leaving your device. And that's an exciting business opportunity for them, number one, because that's gonna help them take down a Google, low key. But it's also going to help build that user trust. So I think that on-device modeling is something that's really key, but they haven't fully figured out how to make that work without making your phone super duper slow. That being said, there's a lot of really smart people out there, and I believe we can figure it out and have it all, have our cake and eat it too.
Discussion that you guys are having, because we're having so much discussion about the choices that we have to opt in and opt out, but what about our most vulnerable populations, like the children who have no choice on whether they can opt in or opt out? Are there a lot of discussions on this level about Meta and the controversy that we're seeing with children's data being sold, these minors who have no choice in what they're doing or what their parents are doing for them? What discussions have you heard of on that side?
There's a lot of discussion out there, and there are children have rights more than adults do. So that's one positive thing. I can connect you with some professionals in the trust and safety space that I think are really having those conversations, but great question. Okay. I feel like we're wrapping.
Yeah, well, let's wrap up. Everybody, thanks to Lauren. Everybody, thank you, Lauren. What a rousing discussion. Great talk. All right, we're just about at the end here. My favorite part, as I mentioned earlier, we've got about an hour to meet each other, chit chat, and maybe continue the discussions with our speakers as well. So before we get out of here, there's just one thing I need for y'all to do. I'm going to channel my senior director. His name is Vlad. He could not be here tonight, but every one of these meetups, he sends specific instructions to our security downstairs, and they've been instructed to not let you leave unless you do this thing. So please listen closely. It's very important. I need for you to reach in your pocket and pull out your cellular device, your mobile phone. Grab it. I'm watching you all. Come on, do it. Do it. You will not be let go. Double click that power button or swipe on the bottom. Pull up that camera phone. Find the person next to you and take a selfie. Make a friend. Scott, I'm coming to you. Great picture. This guy's photogenic. Everybody do it. You will not be let go unless you do it. Did you do it? Did you do it? Did you? Okay. All right. You get in here. All right. Come on.
Okay.
Excellent. Who got good pictures? Did you get good pictures?
Right to opt out? Question mark? No. I'm kidding.
All right. Did everybody do it? Everybody did it? All right. Post that picture on your favorite social media outlet. Share your privacy with them. Tell everybody what a great time you had. Find a friend, maybe even tag them in that and tell them, hey, you got to come here next time. We do this monthly. We want y'all all back. We very much appreciate it every time that you show up, and we want to show that to you. So with that, let's wrap up. Let's have a good time. Let's chit chat, have some more food, have some more drinks. Thank you all. We really appreciate you coming.